Assalamualaikum and good day everyone. So for our second lecture, we will learn about modeling change with difference equation. Okay, so what is difference equation? So now we are learning about sequence of numbers. So for every sequence of numbers or series of numbers, there is a change between one number to the next number. So we are going to model the change by using sequence of numbers. Okay, now sequence of numbers are given in symbol A. A is a set of numbers. Right now, we arrange in the form of a sequence, or it must be in order. The sequence must be in order. It's either increasing or decreasing. For example, A equal to A0, A1, A2, and follows. Okay, the three dot here means it follows the same pattern. Okay, so this is sequence of numbers. So the difference, the A0, 0, 1, 2 represent the position of numbers. Okay, the difference an plus 1 minus an is called n first difference, meaning that the position of the number n first difference and denoted by change of an. So delta, okay, this symbol delta means change. Change means that the two sequence of numbers measure the difference. So this symbol gives the difference between the two consecutive numbers. For example, change of A position n equal numbers at position n plus 1 minus number at position n, where n is given by 0, 1, 2 and so on. So this is the order of number, the position of number. Okay, geometrically, the first difference represents the vertical change in the graph. Vertical change in the graph means that by looking at this graph, the vertical change meaning that this is number at point n. So we can use any point here. Let's say we take this point. This is number at position n, and the next one is number at position n plus 1. So the difference in the vertical change, meaning that we have this vertical change, meaning y2 minus y1. The change between the difference between y2 and y1 is the change, the vertical change in the graph. So the vertical change would be the delta an. Alright. Okay, we take this example. Example of saving certificate. Consider the value of a saving certificate initially worth $1,000 that accumulates interest paid each month at 1% per month. So we are going to model the difference made by these problems monthly. So what will be the difference equation? So we are going to model this problem. Okay, let A sub n be the value of the certificate after n month at 1% per month. The interest paid each month is incurred 1% per month. So let an be the value of the certificate after n months. Okay, now the initial worth is $1,000. It means that the initial value, the starting number should be A0. Okay, n position should be A0. A0 given is 1,000. Okay, and because of the interest given is 1% per month. So the change in A0 is the amount at A1 minus amount at A0. Okay, the interest incurred is 1%, so it means that it is incurred on A0, the initial value, which is 1,000. Okay, and the rest follows as the following. Delta A1 is A2 minus A1. Okay, until delta AN is an plus 1 minus a naught, an. Okay, since a delta a naught is a1 minus a naught, we know the initial value, the interest is 1%, which is 0.01. Convert it into decimal numbers. 1% is 0.01 multiplied by initial value was 1000, which is a naught. Okay, and the rest follows as delta A1 is A2 minus A1, delta A2 is A3 minus A2, delta A4 is A5 minus A4, and so on. Okay, it goes like the following patterns. Okay, so the last equation, so from the sequence of change, we can write the equation as delta n plus 1 is an plus 0.01. Okay, not delta. This is the rearrange of this one. Okay, rearrange of this one. We put the value at point n plus 1. Okay, an plus 1 is an plus 0.01 an equal 1.01 an. So we have from this equation an plus 1 is an plus delta an. Okay. Okay, since delta an is an plus, okay, from here an plus 0.01 an. Okay, which is, this is 1 here plus 0.01 become 1.01 an. Okay, so this is how we get this equation, which is and with initial value given is $1,000. So this is the complete equation for term A sub n plus 1. Okay, for term at position n plus 1, it is given by this equation, the model. And we must put the initial value A naught together with the equation, so that we complete the system. And the equation is called, here is called dynamical system model. Okay, dynamical system model. The last equation can be written as this one, which is the last equation. Okay, the last equation is called dynamical system model, and the equation is the complete one. The complete equation, this last one, the last one is called dynamical system. Together with the initial condition is called dynamical system. The final equation that we obtain from this recursive equation, we call this dynamical system model. Okay, now example, consider the value of saving certificate initially worth RM1,000 or $1,000 that accumulate interest paid each month at 1% per month. So this example is about the same with the earlier example. The interest rate given is 1% per month. We withdraw $50 from the account each month. The difference between the earlier example is that in example 1.1.2, we do not withdraw any amount from the account. Okay, so in next example, this example, we withdraw $50 from the account each month. Okay, now let's assume A sub n be the value of the cert after n month. Then the initial value is 1,000, and because of the interest and the withdrawal, we have change delta an is an plus 1 minus an, which is 0.01 an minus 50. So every month we deduct $50. Okay, so this example, earlier example, the same as what we have in the example 1.1.2. We have this equation. Same also goes with this example, this equation. But now since we withdraw monthly $50, so we add another minus 50 in the equation. Okay, so the numerical system is given by an plus 1 equal 1.01 an minus 50 with a not equal to 1,000. Okay. Okay, now next example, mortgaging a home. Okay, this is a bit different because here we have a going down sequence of numbers. Right, so we want to make sure when will be the time we finish pay loan, the home loan. Alright, so we have mortgage a home for a certain amount of money, and then we need to predict until when we will finish pay the loan, right? So this is about mortgaging a home. Okay, 6 years ago, your parents purchased a home by finance $80,000 for 20 years. So this is a common loan that we do in banks. If we were to buy a house, we have to buy any property, so we make loan, right? And the monthly payment of $880.87 with a monthly interest of 1% incurred by bank. So currently they have made 72 payments already. Currently they have made 72 payments already. Now how much do they owe on the mortgage? So we want to find out how much balance do we still have in order to complete our payment, our loan. Okay, so we do the same process as we did earlier in the two examples. Now let B sub n be the amount of money owed to the bank after n month. Then we have delta Bn is Bn plus 1 minus Bn. So this is the equation of change we do from the early part of the modeling change. So this is the equation that we have. Delta Bn is Bn plus 1 minus Bn, which is, look at the interest incurred here is 1%, so therefore become 0.01 Bn. So minus 880.87 because we, this is like we pay monthly. So since we pay monthly, so it must be reduced. The amount that we owe bank must be reduced monthly by 880.87. Okay, so rearrange this equation. We obtain Bn plus 1. Okay, from here Bn plus 1 is 1.01 Bn minus 880.87 with initial value B0 given by 80,000 ringgit, $80,000. This is the loan amount that we loan from bank. Okay, now by doing tables, it's easily if we can compute using table, so we can see until which month do we finish pay the bank. Okay, start from month 1, we owe bank $80,000, and then in month month 1, so we deduct the amount by 880.87, so we just plug equation in here, okay, where bn plus 1 here become 80,000. bn plus 1 become 80,000, okay. bn here become 80,000. B naught, okay, it should be B naught. Okay, B naught is 80,000. B naught, put it in here. So we have the calculation is B1. Month 1 is B1. Month 1 is B1 is 1.01 B naught minus 880.87. So we have 1.01 time B naught is 80,000 minus 880.87. Okay, solve this. You will get this value, 79919.1. Okay, next for B2 here. Okay, B2 become 1.01 B1 minus 880.87. So we have 1.01. B1 is this value, 79919.1 minus 880.87. So answer should be the second month 2 value, 798.37.5, okay, which is given by the second value. So we follow the same process to get B3, B4, B5 and so on. Okay, B3, B4, B5, we continue with this one, same process, and finally we will have values given by this table. So we do this until finally we get value which goes to 0, to ensure that our loan with the bank is done. Okay, so the value should be 0. So from here we do it one by one, and we obtain that until 240 months the value become negative. We may not get exact 0. Okay, this is not possible we get exact 0, but we get value which is close to 0, meaning that so that's the month that our loan is complete, finished. Okay, by looking at the graph using this table, so this is what we get using graph. So we have from starting from the initial loan, amount of loan, we loan bank 80,000, and monthly it goes down until it reach values of loan become 0 here. So this is number of month where we have done the payment.